Alright, let's get started by accessing Google Colab. The simplest way is to type Google Colab into your search engine. Once we're on the Google Colab page, we have two main buttons: Open Colab and New Notebook. The New Notebook button will jump right into a fresh notebook, but I want us to take a look at the initial dashboard first. So let's click on Open Colab. Now that we've clicked on Open Colab, we're taken to the main dashboard. This is where you have a few options to get started, and it's great to understand each one. You'll see options for Examples, Recent, Google Drive, GitHub, and Upload. Examples gives you pre-made notebooks that can help you learn different concepts. Recent shows notebooks you've worked on before, so you can quickly get back to what you were doing. Google Drive is the best option if you want to save and organize your notebooks in the cloud. GitHub lets you pull in code directly from your repositories. Upload allows you to bring in notebooks from your local machine. To start our journey, we're going to click New Notebook. Think of this as creating a new spreadsheet in Excel, only instead of entering numbers, we're going to be coding in Python. We've now arrived at our main working area. This is where we'll be writing our code and seeing how everything works together. But before we dive into coding, let's take a moment to get familiar with the interface itself. File tab overview. The File tab in Google Colab provides options for managing your notebooks. You can create, open, and upload notebooks, save your work to Google Drive or GitHub, and download your notebook to your local machine. It also allows you to rename, move, or delete notebooks, as well as access version control features like saving revisions and checking your notebook's history. The Edit tab in Google Colab provides tools for managing and editing your notebook. You can undo and redo actions, select or manipulate cells, and use features like cut, copy, and paste. It also offers options for finding and replacing text, adjusting notebook settings, and clearing all outputs. The View tab in Google Colab allows you to adjust how the notebook is displayed. You can toggle the table of contents, view notebook info, and check the execution history. It also provides options to show or hide code and output, collapse or expand sections, and navigate between tabs or panes. The Insert tab in Google Colab allows you to add various types of content to your notebook, such as code cells, text cells, and section headers. You can also insert a scratch code cell for temporary code, use code snippets for quick access to common code, and add form fields to create interactive elements in your notebook. The Runtime tab in Google Colab provides controls for executing your code. You can run all cells, run specific cells, or run cells before or after a selection. It also allows you to interrupt or restart the runtime, manage sessions, change the runtime type, e.g., switching to a GPU or TPU, and view resources or logs for debugging and performance monitoring. The Tools tab in Google Colab gives you access to the command palette for quick actions, settings to adjust preferences, keyboard shortcuts for efficient navigation, and the option to compare diff notebooks to see changes between versions. The Help tab in Google Colab provides access to frequently asked questions, release notes, and a code snippet search tool. It also allows you to report bugs, send feedback, and view the terms of service. The Table of Contents panel in Google Colab helps you navigate through different sections of your notebook. You can quickly jump to any part of the notebook based on headers. The panel also provides icons for searching, inspecting variables, accessing code snippets, and managing files stored in your notebook or Google Drive. The Plus section button lets you add structured sections for easier navigation. The Find and Replace panel in Google Colab allows you to search for specific text within your notebook and replace it. You can customize the search with options such as case sensitivity, whole word matching, and using regular expressions. You can replace a single instance or use Replace All to replace every occurrence of the search term throughout the notebook. The Variables panel in Google Colab, also known as the Variable Inspector, displays all active variables in your notebook, along with their names, types, and shapes, for arrays or data frames. It allows you to keep track of the variables you've defined, but keep in mind that leaving this panel open might affect runtime performance. The Secrets panel in Google Colab allows you to securely store environment variables, file paths, or keys, example API keys. These secrets are private and only accessible within the notebooks you specify. You can add new secrets by clicking Add New Secret and access them in your code using the userdata.get function from the Google Colab library. The Files panel in Google Colab allows you to manage files within your notebook environment. You can upload, download, and view files stored in the session. The sample data folder typically contains some default datasets. You can also refresh the file list or connect to your Google Drive for accessing files stored there. The Code Snippets panel in Google Colab provides quick access to commonly used Python code snippets. These snippets cover various categories, such as working with files, data processing, and machine learning. You can easily insert these pre-built code blocks into your notebook to speed up development or use them as reference for common tasks. It's a great tool for beginners and those looking to quickly implement frequently used functions without writing code from scratch. Command Palette in Google Colab provides quick access to a wide range of commands, like showing the table of contents, the variable inspector, or code snippets pane. You can also perform actions such as adding code or text cells, forms, and section headers. This tool helps you efficiently navigate and manage your notebook by searching for and executing commands directly. By signing up for Colab Pro, you gain access to additional features, including faster GPUs and TPUs, get access to better and faster hardware for machine learning and data processing. Longer session runtimes. Colab Pro allows longer runtimes, reducing the chances of session disconnections during long computations. More RAM. With Colab Pro, you have the option to access more memory, useful for larger datasets or memory-intensive tasks. Access to a runtime terminal. This gives you direct access to the terminal on your runtime, useful for executing shell commands. If you regularly work on resource-intensive projects, Colab Pro offers significant benefits in terms of performance and convenience. The disk size you see in the bottom left corner shows the available space in your Google Colab environment, which is a temporary virtual machine, VM, that resets every time your notebook is closed or the session is disconnected. This group of icons in the top right corner of Google Colab provides access to various features. Comment allows you to add comments or notes in shared notebooks, useful for collaboration or feedback. Share. This button lets you manage sharing permissions for your notebook, similar to Google Docs. You can invite others to view, comment, or edit the notebook. Settings, gear icon, provides access to notebook settings where you can configure display options like theme and font size or adjust runtime preferences. Profile displays your Google account profile associated with this Colab notebook. Clicking on it allows you to switch accounts or view account details. RAM and disk usage displays the current usage of your RAM and disk storage. These bars show how much of your available memory and disk space is being used during the session. For the coding, I'll pass you over to Jerry.
Thanks, Tom. He'll take over from here. So, after we explore the Python interface, it's time to write our very first code statement, the classic "Hello World." We use the print function to output a string. This function is essential, especially when debugging, and even seasoned developers rely on it heavily to track processes and get useful information. This simple statement prints "Hello World" to the console. Now, let's move on to variables and data types. Understanding these is crucial for working with data in Python. Here are the key ones: string, integer, float, and Boolean. Each variable holds a specific type of data. Name is a string, age is an integer, height is a float, and his student is a Boolean. Knowing which type to use helps in managing data effectively. Lastly, let's touch on basic arithmetic operations: addition, subtraction, multiplication, and division, which are the foundation of working with numbers in Python. These operations are straightforward, and you'll use them often as you build more complex programs. Now that we've covered the basics, let's move on to control structures and data collections in Python. These tools allow us to make decisions, repeat actions, and manage groups of data. First, if statements. the backbone of decision-making in Python. They help us run specific code based on whether a condition is true or false. For example, you can check if someone is an adult based on their age, and take actions accordingly. Next are loops. Loops help us repeat actions without rewriting the code. We have two types. For loops, which are ideal for iterating over sequences like lists, and while loops, which run as long as a condition is true. Now, custom functions. Functions allow us to bundle code together, making it reusable. This way, you can write a function once and call it whenever you need that functionality, keeping your code clean and efficient. Then we have lists, a way to store multiple items in one variable. Lists are perfect for managing data collections, like a list of names or numbers. Lastly, dictionaries let you store data in key-value pairs, which is useful for associating information, like a person's name and age. Together, these control structures and data collections help you take control of your code, making it more organized and powerful. Once you've got Python set up, let's take a look at some common libraries that are built-in and easy to use. For example, the math library is perfect for performing mathematical operations, and the random library is great for generating random numbers. No installation needed. They come with Python. Now, for external libraries like matplotlib, which is great for creating charts and visualizations, you'll need to install them using pip. Once installed, you can import it just like the others, and that's it! You now have access to powerful tools built right into Python, plus external libraries like matplotlib that are easy to install and use. Let's explore a small project in Google Colab, where I prompted Gemini to create a basic calculator. The best part about today's tools, like Gemini, is that you don't need to memorize every line of code. Instead, having a strong foundational understanding is enough to appreciate how things work and customize them as needed. With Gemini embedded in Colab, I simply provided a prompt, and it generated the code for a basic calculator. This saves time and allows you to focus on understanding the logic and how the code is executed, rather than worrying about every single detail. You can experiment, adjust, and run the code instantly in Colab, making learning both flexible and efficient. And there you have it. We've explored the basic interface of Colab, covered essential data types and structures, used libraries, and even tackled more complex code with the help of Gemini. This is definitely a win. In the next session, we'll dive into the world of data extraction, working with CSVs, JSON files, and more. Extraction is a crucial stage in any data analysis project because it serves as the foundation for deeper, more complex insights. Mastering this step sets you up for success in any data-driven project.